Hi, everybody. My name is Gavin Bowman, and I'm a backend engineer here at Stately. For our last video, we covered a very specific backend use case for modeling our long-running processes as a state chart, and specifically using Stately tooling to do it. We covered some of the basics like transitioning from one state to the next, managing long-running processes, and updating our context as we went along from one state to the next. So in this video, I wanted to double click on some of those concepts and dig a bit deeper, as well as cover some new ones that we weren't able to touch last time around. So specifically, I'd like to talk about state hydration, wherein we make sure that we are able to manage very long-running processes when we don't necessarily have control over the compute and how long our actors are going to be staying in instance memory. So we'll cover that. We'll also cover parallel states, kicking off a bunch of processes at once, collecting all their results at the end before moving on to the next one. And finally, we're going to be talking a little bit about final states and how they can relate to backend processes to let us know when our actual flow is done. So without further ado, I'm going to go ahead and switch on over to our actual example and give more context there. Okay, I know this is very difficult to see, but before we zoom in and take the demo step by step, I wanted to explain exactly what it is. This is what I envision a long-running credit approvals workflow to be. The inspiration is the difficulty and grief that Americans have to go through for home loan applications. So let's get started at the beginning. So we started entering information. The scope that I considered when building out this flow is that of a backend API that has some route sets listening for any events received by a front-end web app. So in this initial state, entering information, I'm envisioning it to be just a website with a form and a submit button. And when that submit button is hit, you can see we've got an expected event schema associated with the submit event. So I'm looking for the social security number, which is a unique identifier for Americans. I'm looking for a last name and a first name. From there, we move over to a credential verification step, just making sure that this person is real and exists. This demo is actually built with MongoDB as a backend. And so whenever we actually talk about verification or state hydration, we're actually saving and reading to and from that database. Okay, so let's assume that everything goes well. We move over to this big meaty state that we've called checking credit scores. But before we dive into that complexity, I'm just going to head on back over to this on error event. So if something does go wrong, what I, as the API, will do is immediately kick back, say I can't verify this user exists or is real. And so I will update my context with an error message and send that along with the rest of my context back to the client, whoever called me. Okay, but nothing ever bad happens in software development. So let's move on as if everything is rosy. So over here, in our checking credit score state, you can notice that this big state is green, but the state under it is purple. So for context, just like our last video, I'm highlighting all our happy path states in green, all our sad path states in red, error handling and things like that, our neutral things in blue, and since we're covering parallel states as a new topic here, I wanted to highlight those as a different color. So in this case, parallel states will be purple. Okay, so if we zoom out again, you can see that checking Gavin, which is the name of our fictitious credit bureau, is not the only thing that has to happen at one time. Our API has to dispatch your user information or whoever your end user's information is off to all the different credit bureaus that matter. So in this use case, it's Gavin, Gavin, and GavUnion. I wasn't sure if I could use the actual name, so that's what I went with. And in this case, if we zoom out just a little bit, in this case, you can see the flows are virtually the same. And that is done intentionally because in my flow, they all happen the same way. But you can see that in parallel states, just because you're running multiple tasks at the same time does not mean that those tasks have to be exactly the same. So you can model these to accommodate for the intricacies or differences for whatever credit bureau you need to hit at that time, which I think is pretty cool. And you can think of a parallel state as just a mini state chart. You can see This little icon here means that this is its initial state. So all of these parallel states start at checking for existing report. And if you head over to the far right here, you can see that it's got two possible options for final states, where the fetching has been completed or where the fetching has been failed. The exact same as our master state chart has. It's got an initial and it's got a final state. But let's walk through the flow and make sure that we understand actually what this whole process is. So in this case, for checking Gavin, we want to make sure that we don't already have that end user's credit information or in credit decision on file already. We don't want to overrun his information on a credit report because it can actually hurt your credit, which is why I thought this was a good edge case to consider here. So the first thing I do is make sure that there actually is a report. If we find a report, we can determine with our little guard here. Guards in XState, you can think of them as control flow logic in any other programming language. So this is just an if-else conditional here. And you can add as many else-if conditionals as you need. So in our case, we are saying, hey, we found a report. We don't need to hit up another one. We go straight over to our fetching complete state so that our report can actually be used in subsequent steps. But let's say we didn't find a report. So if we didn't, now we know that we actually have to take our user information and run it against the credit bureau for a report that we can hold on to. So we move over to our fetching credit report state. We check our bureau here. You notice in all of these instances, I'm talking to external services. So whenever I want to talk to an external service, that's probably going to be an invocation. And invocations are perceived as actors in XState v5 and in Stately Studio. You can think of invocations just as a reminder as an activity that gets kicked off that we want to wait on. We want to get the end result. So that's what these on-done events are actually covering here. They're just hooked into our invocations, and we know when it's been finished. In our case, they're a bunch of from promise-based actors. So when that promise resolves is when we know that we get our on-done or our on-error event. So after we've checked the credit bureau, assuming everything went well, we move over to fetching complete. And you can see that in the case of this parallel state, fetching complete is final. So we know once it gets here that the checking Gavin state is finished. Otherwise, if fetching credit report doesn't work out, something fails, something goes wrong, we have a fetching failed state, which is also a final state. In either case, we want to save something to represent that. So if everything goes well, we want to save our results to the database. And if everything does not go well, we want to update our context with our actual error message. Now, the presence of the final state in a parallel state is really important because it is the only way that our parent state knows that it's actually finished with all of its children. And once that happens, once all of these individual actors, you can call them, or once all these individual parallel states have been finished, we are able to hook into the on-done event for that parent state, which, if we move over a little bit and we zoom on in, looks like this. It's our on-done. And you can see we have another guard here. Because it's possible to reach either the fetching complete state or the fetching failed state, we want to make sure that we don't do anything with the user's final decision until we have all of their credit decisions back. So if everything goes well, we move on to another little mini flow here, which we call determining interest rate options. Otherwise, we go back to entering information with the updated message in our context saying, hey, this is what went wrong. Once we're in determining interest rate options, you can look at this as a completely different service if you wanted to. It could be the exact same service running on the exact same server, but it does not matter as far as XState is concerned. It's just another actor. So I wanted to illustrate that here. So in determining interest rate options, that is a parent state with its own little subflow going on here. We start to determine the middle score, which is something that after we get all the information back from our bureaus, we pick the one in the middle, and that's the one we use to determine if you're credit worthy or not. So we have a state to do that. As we come into determining that middle score, we invoke the function to actually do that. And on our way out of that state, we have an exit action. So on our way out, after we've determined what the middle score is, we assign that middle score to our context. And just as a reminder, we've got our social security number, which is a unique identifier for Americans, our last name, first name, and the individual scores for all of the credit bureaus. We also have some initial values set. You can see they're all set to basically nothing. Some value is a really great placeholder. Okay. So once determining middle score is done, we move on over to fetching rates, which could again be another service that we hit. At that point, once it's done, we end up moving to a rates provided state, which is a final state letting us know that, hey, we're done with this particular flow. And so at that point, we have some actions to email the end user, letting them know of their credit decision. And we have another action that's emailing the sales team to let them know when to call and harass the end user. Okay, so that's basically the flow. I do want to cover what happens briefly if all of these parallel states do not succeed. So we do have an else conditional here. So if they don't all succeed, what we do, like I mentioned, is head back up to the entering information state. Now, again, this doesn't necessarily mean we send everything back to the user on that sign up form. What we're really saying is we're returning this response back to whoever called us saying, hey, we can't do anything with this, and we're setting our state machine back to the beginning so that we could reprocess if we needed. And again, if we did need to reprocess, we don't have to worry about double running the end user's credit report because we have this checking state here to make sure that we don't already have it on file. Okay, well, that's about the end of the explainer. Now let's move on to see it in action. On to the demo. So we're going to walk through the flow of events. We're going to see it working first, and then we're going to jump in the code and see exactly what needs to happen on the implementation side of things to enable things like state hydration, for example. So to start, this is a very simple Node.js Express API with 3 endpoints, 2 post endpoints and a get endpoint. The first workflows endpoint here actually kicks off the entire flow of things. It starts the actual workflow, wakes up our initial actor, gets us a workflow ID that we can then use to query. So our get endpoint is just for that. It lets us query to see where our workflow is in its overall lifecycle. And finally, the last post endpoint is what we use to submit events to that running workflow to make sure we can actually move things from point A to point B. Okay, so let's start it off. Here we go, send an event. You can see we've got a 201 created response here saying, hey, our new workflow was created successfully. We've got a workflow ID, which I'm going to copy. You can see off to our left here, we've got console output that will pretty much match the actual status of our workflow. You can see our initial status here is entering information, just like in our state chart. And if you want to doubly confirm that, we can go to our get endpoint here. I'm just going to paste the new ID. There we go. And we'll hit send. You can see there our guy is. Yep, our value is set to entering information, and the workflow ID is the exact same. So let's actually make it do something. Let's send off an event. Let's go over to the post endpoint here. See, it's virtually the same endpoint. The difference is if I give it a parameter, for the workflow ID, it's going to search the database for that running workflow, make sure that it's hydrated and live, and it's going to submit the submitted event to it. You can see in the body of our request here, we've got the event type, our social security number, our last name, and our first name. And this schema matches the schema that we showed off in our actual state chart. So let's go ahead and send it. Great. We can see that we've received the event. We can see that some things are happening here. You can see a lot's happening. So if we go and we check our status, this is sort of a snapshot, a point in time of what's actually happening. You can see right now, by the time I got this response back, the machine was on the determining interest rate option state, which is really cool. And you can see what the context was at that time. It's not exactly real time anymore, though, because as you can see, a lot has happened since then. So if we send this request again, you can see the rates are provided now. We're still in the determining interest rate option state, but we're at the final part of the determining interest rate option state. And you can see here, this is a complete log of all the events that are happening. We'll even show how we achieved that in the actual deep dive for the code. So let's transition over to our repo and see what's actually going on here. Okay, so now that we're in the code, let's explain exactly what's happening here. So like I mentioned earlier, state hydration plays a really critical role in long-running backend tasks, especially for workflows that can span across hours or even days. This is because we don't have a real guarantee that we're going to be holding on to the same context, the same compute that we did when we started. So in that case, the best thing we can do is when we receive an event, make sure that we save off our current state after any transitions have been made. And when any new events are received, whether they be by us hitting a request or one of the invocations that we kicked off reporting that they are finished, whenever that happens, then we wake back up again, look at our backing database store as the source of truth, hydrate or restore our actor back to that previous state, take our new event, transition to the next state, and then execute all the actions and invocations associated with that. And then it's a rinse and repeat. So let's see how we actually do that. So like I said, we've got these 3 endpoints here, one for workflows, a post with the ID, and another for getting the actual workflow by its ID. So let's look into the actual post for a new workflow here. You can see we're just creating a new actor. I have this function here called getDurableActor. So let's see what that actually does. All right, now that we're in here, we can see that we've got this notion of a restored state. If we were given a workflow ID in this function, we can assume that, hey, we're probably going to be continuing from where we left off. And so if we have a workflow ID, we try to find the associated state object from our database. In this case, again, we're using MongoDB. If we don't have a workflow ID, well, we can assume that this is a net new run, in which case we generate a brand new ID for it, and then we create our actor with that associated ID. So once we've created our actor, we now want to make sure that that actor understands that it has to save itself to the database every time it makes a transition. And this is where XState's actor subscribe function comes in, which is very handy. So we can say, hey, the subscribe function takes a function as an argument here. It's got a hook in there for next. And so I'm saying, hey, on every next transition, make sure that you get a snapshot of where you are now, persist that state to the database, find the old record by its workflow ID here. This is the MongoDB call, and just replace it all together with the workflow ID and the newest persisted state that we have. And I've got upsert set to true here, just in case we actually don't have a previous record with that same workflow ID. And this is a net new run. And we know, hey, if there's not one, just make one for us. Okay. We've also got some logic in here to make sure that, nothing goes wrong. And if it does go wrong, we report it. Another thing I'd like to talk about in this actor.subscribe function here is that we have 2 other hooks. So we've got the next hook, which is great. We also have an error hook, which is signed up to happen whenever something goes wrong in our actor. We can have a means of reporting out to the outside world. And so that could be anything from sending an email to an admin. It could be, if it were instant report, throwing an error all up. It could be anything of that sort. And we also have a complete hook, which is what we want to make sure that we do when the actor is actually done. It doesn't need to progress on this workflow anymore. And the way that we determine that, again, is with our final state in the workflow. And so at the very end of defining that, we start the actor and we return it back to the calling function, which lives on our route. Okay, so you can see that if we go back to our index here, this is for creating a brand new workflow. If we want to actually update that workflow, you can see it's very similar, except we actually care about the event. So we get the durable actor, same way we did the first time, except this time we're giving it a workflow ID. So we know that, hey, this workflow exists. We're going to hydrate from MongoDB, and we're going to send it an event. And the cool thing, again, about XState and state machines altogether is that if that event is illegal, if it can't transition, it is not going to, right? So you're never going to hit an instance where, oh, I double submitted for an end user's credit report or something like that, which is pretty cool. At the very end, you can see our get endpoint to actually check on the status of a running workflow. You could do this one of 2 ways, actually. You could hydrate the actor and start it up again and return it and get the state from that actor, or you can rely on that actor's very own source of truth. Since we're just reading from it, we just need to look at the database. So in this case, we're just doing a MongoDB call for our machine states here, and we're finding one by our workflow ID. Next things next, let's go ahead into our machine here, and we can see the full-on TypeScript and JSON representation of all of our states. So you can see if I go ahead and using our handy-dandy visual editor, you can see I've got the exact same representation of the state machine that we had in Stately Studio. So everything that is defined there is also present here. Okay, and like I mentioned before, we have all our actors defined for checking the bureau, checking the reports table to make sure a report exists, verifying credentials, determining our middle score, and generating our interest rates. Now, in the output from our demo, you might have missed this, but you might have also seen that our interest rate is set to, our only option that we get back is 200. That is because, again, we determined our middle score, and you can see our middle score right now is 431. And if we go back to our code, in our logic for generating interest rates, if we click that function here, you can see that my little logic is a bit heavily skewed over towards higher credit. So if you're under 600, then yeah, you got that 200% interest rate. You're gonna have to do something about that. But anyway, this was a really fun demo to go through, especially modeling the long-running tasks. I did that with just this sleep function here, just a random number between 1,000 milliseconds and 10,000 milliseconds, just to sort of simulate events rolling in instead of everything happening instantaneously and coming in all at once. All right, so that's pretty much the demo. That's how the code looks. If you'd like to play around with this demo for yourself, feel free to check it out. It's hosted on GitHub, and the link is in the description. That's about it, y'all. I hope you guys found this useful. If there's anything specific that you'd like me to cover, feel free to mention it. Find us on Discord. And until next time, have a great one. Bye.